Hey there and welcome back to the Code Wrinkles channel for a brand new video about software architecture. And in this one we'll talk about clean architecture in ASP.NET Core but with CQRS and Mediator. And this is a very nice topic because it actually builds upon what we have done in the previous video that we talked about software architecture, in which we have looked into how to structure a clean architecture application in ASP.NET Core, but following the what I would call a standard approach, or the most common approach, where you will have repositories and where you will have services. Now, in this one, what we'll try to do is basically implement the same clean architecture concepts, but instead of having repositories and services, we'll replace them, as we'll see, with handlers and comments and queries and handlers for those comments and queries. And this is really not very fancy or not very spectacular or not very complicated, but there are some things that I would simply want to go through. Now, if you are totally new of this concept of clean architecture, then please pause this video and maybe go to the previous one. You can find it in the description of this video or somewhere here in the corner upper right, and go to that, as in that video we'll discuss the concepts, the basic concepts of clean architecture. And if you need to get started with that, you should go to that one. What I would like to do right now is start and discuss a little bit these new concepts that we want to introduce in this video. And there are two of these concepts. First of all, what is actually CQRS? And secondly, what is Mediator and what is the Mediator pattern and why do we need that? So let's get started first with CQRS. And for that, I would also like to go to this blackboard to explain a little bit what this CQRS means. Now, in order to understand how or what CQRS brings to the table, by the way, this is an abbreviation for Command and Query Response Segregation. But before we go into that, let's try to understand what exactly happens in a very traditional application. So I would draw here something which would be, I don't know, maybe my web application, or we can simply think about this as being our controller. Now, then we have here a client, somebody that actually makes a request here to our controller. Now, this request comes to our controller, and the controllers, actually what they have here are probably a lot of services. Okay, no, I don't want to have that. Let's just click undo here. Okay, so in this controller, we might have a lot of services, but I'm not sure exactly what happens here. Sorry for this one. The idea is that we might have then a first service that we have in this controller. Let's call this S1. We have maybe a second service that we have in this controller, and this is S2. And we have a third service in this controller, and we could have, usually we have more than 3 services in controllers when we follow this regular or very standard approach. Now, the idea is that the controller will become here in this approach a very messy class, because when a request comes in, the controller will have probably injected a lot of services because it would have several actions, and in some action maybe you need service 1, in another action you maybe need service 2 or 3, in a different action you might need all 3 services, and so on and so forth. And of course those services might have other services that are injected in them. For instance, in each service we might have different repositories that we inject, or a bunch of different other services. And you can then maybe already get an image about what how messy a controller can get. Now, what these services usually do is they will talk to a data access layer in one way or another, usually through repositories. So let's have this data access layer, and the data access layer in the end actually talks to a database. Okay, let's call this DB. Cool. And this happens, and of course, in order to generate a response, it will also happen that we will also travel the other way around, so from the database to the data access layer, from the data access layer back to our controller, and the controller then processes the response from the service, and it actually generates a response. Now, we can also think about what requests usually do come in from our clients. And let's have maybe here another square or like that. So we can have, for instance, get. Okay. In order to get data, we might have also post, of course. To post data, to create data, we might have then put for updates or patch, but the idea is the same. And then we would probably have delete. Okay, let's just call del. Now, if we think a little bit conceptually, what do we actually try to achieve using these HTTP verbs? And this maps perfectly to this concept of CRUD, so create, read, update, and delete. Now, of course, here the order is a little bit different, but if we think conceptually, what do all these type of methods do, or HTTP verbs? And we can actually make here, for instance, but it always happens this way, and I'm not sure exactly why, but the idea is that what we can do here, we can draw a line here, because conceptually these get requests are requests that actually don't change the data in our database. They are purely queries. We can call them queries. Okay, so query. Okay, cool. And now post, put, and delete, these are the type of requests that actually change something in our database or change the entire state of the application. Because in the end, something will be written in the database, even if it will be deleted, that's still a write. And we can simply think about this conceptually as being a command. Okay, so this means that conceptually, when we get a request, we either want to just retrieve data via a query, or we just want to actually change the data, and we can consider them then a command. Now, what CQRS brings to the table is that, well, we can actually try to actually change a little bit the way that we perform things based on this, or if the request is actually a query or if it is a command. And let's try to actually rewrite everything using this new concept, and here we'll introduce the CQRS. So here we have the client, and here we have our application, okay? It could be our controller. So let's name this once again C from controller. So it makes a request, but in this case, depending on the fact, if this request is a get, then it will be a query. So it arrives as a query, and let's just name that Q. Or if we have another request that changes the state of the database, that would be a comment. And let's name this with CO for comment. Of course, there could be another request that would be also maybe a query. Once again, and maybe another request that would also be a comment. So let's name this once again CO. Now, the idea of CQRS is that we would have to segregate or differentiate the way that we handle queries from the way that we actually handle comments. And for that, we usually have something, or for each type of query or command, we have a dedicated handler. So this means that from our controller, what we will actually do here is that we will have, for instance, here a handler 1 that is responsible for handling only this type of query. Then we might have here, for instance, another handler. So for each type of query or the command, we have here a handler. So that would be handler 2. For this query, we would have another handler, and it would be handler 3. Let's also put this like this. And of course, for this one, we would have then a dedicated handler once again. that would be handler 4, okay? So I guess that should be interesting enough. So here we can already see that we have a segregation. So we have actually for queries, certain handlers, and for commands we have different handlers. But if we go one step further, the idea is that for each type of operation, we would have a dedicated handler. So what actually next in CQRS? Because it's not only this concept that we have to use different handlers. The idea is that we would have also in CQRS, so if we go a full CQRS approach, we would have a read database, and we would also have a write database. Okay, let's write and database. Sorry for that. Okay, so it means that when we have a query, the handler will use the read database to get the response, and it will get the response that it needs, and it will send it back to the controller, and the controller will send it, of course, back to the client. Now, this is a command, and the handler, as it is a command and it needs to perform a write, will actually talk to this write database. Now, this third one is once again a query. It will mean that it needs to talk to the read database, and this one is once again a command, so it will also talk to this write database. Now, the only thing is that in this approach, what we would also need is a background process somehow that actually will keep these two databases in sync. And you can achieve this if you work with a SQL database. You can achieve this, for instance, via triggers. So that when we have a trigger here, that it will write something in this read database, so that would keep them in sync. Of course, the pros of this approach is that it distinguishes between reads and writes, and it provides separate databases, and in the end, actually, this will increase the performance of the application. The downside of that is, of course, is that you will always have a very short time interval in which this write database will not be in sync with this read database. So even if we are using SQL and SQLs are fully ACID compliant, as we introduce this concept of read database and write database, we still are here in a scenario where we have something which is called eventual consistency. Now, if you are using, for instance, distributed NoSQL databases like Azure Cosmos DB or AWS DynamoDB, then this type of synchronizing the different database partitions will be done directly by the service. So it's not something that you would have to take care of. So once again, everything in software architecture and generally in computing is actually choosing between trade-offs and advantages. Once again, following this pattern, we get a lot of advantages because our application will be faster. We don't have a bottleneck in the database anymore, since we distinguish read operations from write operations, and we handle them differently. But the downside or the trade-off of it is that it actually introduces also this concept of eventual consistency, even if you use SQL databases, because you will have a short time when these databases will not be in sync after each command is processed by the application. But this is what regular or full-flagged CQRS would look like. Now, of course, there's also the possibility, which happens in a lot of applications, where, for instance, instead of having only one or two different databases, is that we still have only one single database. So let's make this back one to be one database. And of course, we don't need this sync stuff anymore. Now, here, once again, the advantage here is that we conceptually have a differentiations between the way that we handle queries and the way that we handle comments, because each of them will have its own handler. But the downside here is, of course, is that our database will still become something like a bottleneck. But for most of the applications where you would like to probably implement CQRS, using only one database will be sufficient. It's not a full-blown CQRS in this um, organization, but it's still CQRS because we still segregate the way that we handle queries from the way that we actually handle comments. Now, this is what actually CQRS is at its core. Now, of course, the other part is how do we actually implement CQRS at a controller level? Because when a request comes in, okay, we have to create a query, but how do we know exactly which handler should be responsible to actually handle that specific query or that specific comment? In this case, it would mean that we will have to inject all the handlers here in our controller, because we never know exactly which of the handlers we might need. And this introduces another topic which is very important, and this topic is this mediator pattern. Now, what is actually the mediator pattern is that, well, we have here this controller once again that has different commands or queries. We'll just draw them as squares or rectangles here. We don't write anything. So once again, we have these queries or these commands. But instead of making this controller responsible about resolving which handler should handle which type of request, we will actually delegate this to a mediator. A mediator is actually an entity, I would say, that kind of sits between. Here we have the handlers. So this would be, I don't know, maybe age 1. Here we have age 2. Okay, here we have handler 4. And I don't know, maybe another handler, whoever, I don't know, let's call it handler 3. Now, the idea is that we have this mediator and this is the controller. So the controller will not be responsible to actually find out exactly when a comment comes in or a query, which handler should be responsible for handling it. So instead, it will simply call the mediator, and the mediator, for instance, will know that this request should be, for instance, handled by handler 2. For this one, once again, the controller will not actually do anything but dispatch this to the mediator. It will say, hey, mediator, I have here a command or a query. Please find me a handler for that. And once again, the mediator will say that, okay, for this one, it should be the handler 1. And then we go the same thing for this one. And the mediator will say, probably will need this handler. And if we go for this one, the mediator will pick up and say that we will need this handler 4. So I guess you kind of already get the idea. It's basically we have something in between and we say, hey, I have a command, or hey, I have a query, or generally a request. And then this mediator will need to actually find a way to find out or to dispatch or to define exactly which handler should handle that specific request. And that's what actually this mediator pattern is all about. And fortunately, in the .NET ecosystem, we have a very powerful and very popular library that helps us to achieve just that, and which is the MediatR library, written or, well, developed mostly by Jimmy Bogart, which is a very, very, very nice library that adds also a lot of other functionality on top of this mediator pattern, like notifications, like pipeline behaviors, which is something like the implementation of the decorator pattern, and a lot of other very, very nice stuff. So in our clean architecture with CQRS and Mediator, we will actually try to implement these concepts that we have talked about right now. So the CQRS, where we will distinguish between comments and queries, and we will have then here handlers for them, and the mediator part, which is simply we get a request, which could be either a command or a query, and the mediator will then find out or define exactly or dispatch each command or query to its handler. So therefore we will have this mediator. Now let's go back to our rider and start actually to implement this. So what we have here is already the very basic setup that we have already discussed a lot in the previous video. We have here, for instance, a forecasts core, which is actually our core domain. We have a forecasts application, which is our use cases layer. And we have our forecasts infrastructure, which is our data access layer. And here we also have a DB context class. And we also have wired this up here in program.cs, and we use an in-memory database. However, once again, the important thing in this video is not that we get this application really working, although we could do that, but it's actually to make up a mind on how we can use this CQRS approach with clean architecture, and where do we place the different stuff that we have. Of course, for the core part, it's actually the same as in also the previous video on clean architecture in ASP.NET Core. And here we have a very simple model, which is this weather forecast. And the infrastructure layer will stay the same. Here we will have only the data context that will contain a DB set of weather forecast. Now, in this approach, we'll see that actually we don't really need to have repositories anymore. Of course, you could have repositories and inject repositories in the handlers, but we can even here use directly the DB context in each handler. And we'll talk about that a little bit more. Now, the API layer will, of course, also more or less stay the same, and we'll have here this weather forecast controller that right now just simply returns something with a delay of 10 milliseconds, so it doesn't really do much. But the main part that we will work on here is in this application layer or use cases layer, because here, instead of exposing some interfaces for the repositories and some interfaces for the services, we just replace everything with these concepts that we have seen in CQRS. So it means that here in this one, we will have to maybe create here some directories, and we will have a directory for queries. For instance, we will have a directory for, where is it? Directory. We'll have a directory for comments. And we will have a directory, but this should not be a subdirectory. Sorry for that. Not rename, but I want to delete that. Edit and delete. Okay. And let's create it directly here. So it would be a directory. So comment. Okay. And then we'll have here maybe handlers. You might also want to create separate folder for query handlers and common handlers, but for simplicity's sake, right now we just create one folder which is called handlers. Now, let's assume that the first thing that we would like to do is maybe this get all, which will get all the weather forecasts. Now, what we would do here is this. In this case, first of all, we would need to install Mediator as a NuGet package in our API layer in order to be able to actually implement this CQRS pattern. So let's go here on Manage NuGet Packages, and let's try to find the package Mediator. Now, as we are here in ASP.NET Core and we want to use dependency injection, we need to install this Mediator extensions Microsoft Dependency Injection, which already contains the core Mediator project. But it also adds some extension methods for us to make it easy to wire everything up with the DI container that we have in ASP.NET Core. So let's go and install this. And right now we should have this package installed. Now, of course, one other thing that we need to do is that we will need to install the same package also in our application layer, because we will use some interfaces that are from this package. And here, manage NuGet packages. But here we are in a regular class library. So in this case, we might install only this simple Mediator core project because we don't use dependency injection here. So we will just install that here as well. And we should be good to go from the perspective of NuGet packages. Now, the one thing that we need to do is here, first of all, add also or wire up Mediator with the dependency injection container. And we'll have here on the builder services.add MediatR. And the only thing that we will have to provide here is a type in an assembly, where Mediator should perform a scan for all the requests and the handlers and stuff that we will implement right now. So what we'll do here is we'll use this program class in our API assembly to actually get all this stuff. But this is what we would do normally. But we have our handlers and commands and things like that in a separate project. So we would have to provide here a different class from this application assembly. Now, right now we don't have anything here, so let's start to add something. So let's start to add here a new class in the queries and get all forecasts query. That will be actually everything that we will need right now. Now, in order to implement this type of concepts like CQRS, Mediator provides us with some interfaces. First of all, in Mediator, we have only one interface that is the iRequest interface. And this iRequest interface also is a generic interface that would also provide, okay, what do we return as a response from this request? And in our case, we will return a weather list of weather forecast. Okay, and this should be in the reference to format CQRS core. Okay, that would be okay. Good. Now here we would provide also different properties that we need to communicate data actually from the controller to the handler. Now right now for this get all query, we don't need to provide any type of data because we just want to get all the information from the weather forecast or from our database. So we can even leave this blank right now, but it's important that we add this and make this inherit or implement this iRequest interface, because Mediator will actually use this type of interfaces like the request to actually scan the assembly and find all the possible requests that might be available in our application. And as we already have a type, we can go back here to our API, and instead of program, we can simply say that we want to get all forecasts query. Of course, we'll need probably to add a reference to this application layer, which is very, very nice and fine. It's nothing more than that. And we should be good to go with Mediator. Now, as said, for each type of query or command, which in MediaTR is actually or is defined by the iRequest interface, we need a handler. So let's add a new class here in the handlers folder, get all forecasts query handler. That would be our handler. Okay, and here, in order to mark this as a handler so that Mediator will be able to know when it finds or when it receives a get all query to which handler should be responsible to handle that, we need to also mark this or make this implement the iRequest handler interface. Now this is also a generic interface, and it also takes two generic type parameters. The first one will actually define which request should this handler actually handle. And in our case, it would be the get all forecasts query. So this is the first generic type parameter. And the second one is what it actually returns, or what this request should return. And in our case, we have seen that it would have to be a list of weather forecast. Okay. Alt enter, and we should have that. And now we just need to implement the missing member, and this is what actually needs to be implemented. We have this handle method. We have to also mark this as an async. Now the only thing is that here in this handler, we need to inject this DB context. So private read-only data context. Let's name it context. Of course, this would also need to have a direct dependency or a dependency on the infrastructure, because this is where we get our data context from. And we need, of course, the constructor. And in this constructor, we'll also get the data context. Okay, this should be lowercase, of course, and we'll just assign this here, and we will be good to go. Now, what we'll do here is very, very simple. We'll just wait context dot forecasts and to list async, and that would simply return us the list. So that's a very, very, very simple handler. Also, we need to return that, of course. Good. So this will return us everything that we need. So we can go back here in our controller and say here, here we'll need to actually inject the mediator, private read only, and the mediator package is using the iMediator interface, and let's name it like this. And we want to inject this in the constructor iMediator mediator, and we will just assign this here in our constructor, the mediator, but without the plus at the beginning. That was a typo. And we'll assign the mediator instance that we will get through dependency injection. And the only thing that we can do here is, and to make this visible how it happens, we can have here var result equals await. And the only thing that we want to do here is mediator.send. And what we want to send, or we want to send a query there. And the query is a new get all forecasts query. So that's actually what we want to send there. So, and then we will do an OK and return the result, which is the list of our weather forecasts. Of course, right now, probably in our database, in our in-memory database, we won't have any weather forecasts. So we will need to create one. And just to also showcase how it works with a command, let's create a new endpoint here. We'll have public async task of iAction result create. Let's just call this create. Okay, now we need, of course, some attributes here. First of all, we will need this HTTP get. Know that this is an HTTP get, and we'll also need a route. And I guess the route is controller at the top. So the only thing that we need to add to the route is, actually we don't need anything here because this is not a get, it is a post. Sorry for that. I was thinking on get by ID, but what we want to do is just to create one. Now the only thing is that we want to have from body. We could even skip this specification via the attribute, but I want to make it clear. So from the body, we will return, we will get the weather forecast. And that's actually what we want to create, this weather forecast. So in order to do that, we need a command, of course. So let's go back to our application layer, add a new class, and the class will create forecast command. We also use this command. And here, what we need to do, of course, once again, is say that it is an I request. That's this interface from Mediator. Okay, and it is an I request. And okay, so we need to specify the response, and probably what will return is the created weather forecast. Now, the only thing that we need to do here is, in this case, we need to actually communicate some data from the controller to the handler, and we communicate that data through properties that we have in this class. So we will have here a public weather forecast, and let's name is to create, or just name it new forecast. And this is just a regular property that we will use. You could even use records for that, by the way. So there shouldn't be any problem with that. Okay, so we have this weather forecast that we need to provide to the command, which is okay. And then we will need the handler for that. So let's add here in the handlers folder, we'll go and have a new class, and we'll name this create forecast command handler. Once again, to make this a handler, it needs to actually implement iRequestHandler, which takes two generic type parameters. The first one is the command or the request that this handler should handle. Create command, create forecast command. This is what this handler will handle. And then what this will return, and this would be a weather forecast in this case. Now, similar to what we have done before, we need to also add that. We need to implement the interface. This would be an async method, of course. And what we'll need here is a private read-only data context context. Okay. And we'll also need the constructor. And the constructor will also need the data context that needs to be provided through dependency injection. And here we just assign that to the field, and we should be good to go. Now, when we want to create, what we actually do, well, it's actually very, very simple. So we have, for instance, context dot forecasts dot add, because we can add the forecast directly, and we know that we find it in our request. We have this new forecast property that will contain the forecast, and then we can just await, without the underscore, of course, await context.save changes async. That would save the changes, and then we could just simply return the created forecast, because by the time we hit this point, it will be already created in the database. It will also have an ID, and everything will be fine. Now, I guess this is something that we will need to also change here, because we need also in the domain model public int ID get set. Otherwise, it will not work, because Entity Framework will not know exactly what the identifier should be. And I guess we should be good to go with this one. So we go back to our controller, and once again, what we need here is to create an instance var command equals new create forecast command. We can use here the property or the object initializer and say that new forecast equals forecast. So what we actually get from our body. Okay, so we have the command. Now the only thing that we need to do is var result equals await mediator.send, and the mediator will know exactly which handler to execute right now, and we'll just provide the command here, because based on this command it will find the appropriate handler, and then we can just return okay and result. Sorry for that. Cool. So right now we should be good to go. So yeah, let's maybe just run this application and try this out. Okay, build, I want to run this. And it will probably open up Swagger, and hopefully everything will be all right, because if we get errors, we'll don't stay and debug them, because what I wanted to showcase is just the pure architecture on how this should look like. Now here we have this Swagger, we have this weather forecast with the get and with the post. Now if we go and try it out, this will execute something, and we have an empty list, which is accepted. If we try the post out, which should provide us some data, so it's the date, temperature C, I don't know, let's make it like that, and the summary, my weather, and let's just execute that one. and we see that we get back the newly created weather forecast, which is okay. Now, if we go back to the previous endpoint and we click execute, we just get that also back, which is okay. And this is how we actually implement, as you have seen, basically. If we go back to our controller, the cool thing is that, as you might probably know from experience, controllers get very messy very fast, because you would probably need to inject a lot of services here in the controllers, because this method might use 2 services, this method might use other 3 services, and we might have a lot of other methods that use a different combination of services. Now we have replaced everything from that with just this mediator that simply is able to, based on the query or the request that is created here, in this case here or here, this is a comment, it is able to find out which handler should actually accommodate that specific request, and then actually all the services and everything we need to perform that specific action is actually here in the handler. So it's actually very from my point of view, a very isolated and self-contained and atomic setup, because for each request, for each action that we might get, we have only one place that is responsible to handle that. And we will not, or we are not in a situation where we will have to clutter this with a lot of services that are not needed, for instance, for this action, because in the controller, that's exactly what happens. We clutter it with a lot of services, from which one service might be used in only one request, other 2 services might be used in other requests. So the controllers usually will get to be a big pile of mud. And by splitting each type of action into its own handler, it's actually very easy, because we can inject only the things that we need for that specific action and nothing more, which is very nice. And that's a very basic setup of a clean architecture when you are using CQRS and Mediator. And that's actually the scope of our video, and I think and I hope that it is achieved by now. This being said, thank you very much for watching. If you think this content might be useful, don't be shy and spread the word. Share this with your peers, with your friends on your networks. Share this with whoever you might think would find this content useful. Also, please subscribe to this channel if you didn't do that already, and also hit the notification bell to be notified whenever something new happens on this Code Wrinkles channel. This being said, once again, thank you very much for watching, and until the next time, I wish you the very best.